Let's look a little bit more deeply about the relationship between iterators and implicit sequences. So in general, something that gives you back iterators that allows you to walk over the contents of a sequential data set in some order using an iterator is called iterable. So iterable things give you back iterators. Let's look at that difference directly. So an iterator is a mutable object, something that changes, because it's changing by tracking the position in a sequence, which gets advanced every time you invoke next, or call the next function on that iterator, which just invokes next. An iterable is something that creates iterators. So it represents a sequence somehow, perhaps implicitly, and it returns a new iterator every time its iter method is invoked. Now, all the sequences we've seen in the course so far, lists, ranges, tuples, etc., are iterable. Dictionaries are iterable too. They give you an iterator over the keys in the dictionary. And also sets are as well. So, lots of things are iterable. Anything that can give you back an iterator that lets you go over the contents. So we're going to build some stuff from scratch to demonstrate this. We're first going to build a letter iter, which is a class that represents iterators over letters. And then we'll create a letters implicit representation of sequential data. There's just a bunch of letters in a row. And all it's going to do is give you back iterators. So if we say letters from A to E, including A, but excluding E, that will be the letters A, B, C, D in that order. And that letters object is going to give us letter iters every time we invoke its iter method. And a letter iter is going to be a representation of the same implicit sequence along with a marker of what comes next. So if I create two of these, then I have two different markers over the same sequence. And so if I advance the next of one, that's independent of advancing the next of the other. And if I advance the next of the other twice, I still can go back and get the B out of the first one. And we can walk through the two sequences that way. Now there's one underlying sequence, but just two iterators give us two different ways of walking over the contents. Okay, so the first thing we'll do is we'll create a class, letter iter, which is actually extremely similar to range iter. So we're going to start with the implementation of that. But what we're keeping track of is not the next number, but the next letter, where start starts out at A and then ends somewhere else. Let's say E by default. I'm just putting these default values in here so that you know the kinds of things that are represented by start and end. So we're going to remember the last letter. We're going to remember the next letter that we're going to return from this mutating letter iterator. And if that next letter is too big, you can compare letters by alphabetical order. If it's too big, then we'll raise stop iteration. Otherwise, the result will be the next letter. We're going to change that next letter somehow, and then we'll return that result. Now, how do we actually get the next letter? Well, if I have A, I can get the ASCII representation for A, which I can add 1 to, and I can turn that back into a character. And so I'll do the same thing here. Generally, I'll ask for the character that is the current result plus 1 in its ASCII representation. Okay, let's try this out. So if I load this file and I create B to E is a letter iterator starting at B and ending just before E. Then the next element in B to E should be B and then C and then T and then we're done. So we've created a way of iterating through an implicit sequence of letters, just like we did with numbers. The point of this is just to demonstrate that you don't need to only represent numbers, you can represent any sequential data as long as you can get the next element from the current element. And it's pretty easy to create an iterator. Now what about this iterable? So letters is the class, which very similarly takes in a starting value and an ending value, which are both letters. And this is not going to change. We'll just create the start and the end attributes, which refer to these two elements that are passed in on construction. Now letters is iterable, meaning it has an iter method, which is going to return an iterator. And in particular, it will return a letter iterator that starts at the starting value and ends at the ending value. Okay, how do we use letters? Well, first we'll create S as a sequence of letters from A to E. Then I'll create an iterator for S. And I'll actually create another iterator for S. So S is a letters object starting at A, ending at E. Si is a letter iter. Sj is another one. If I ask for the next Si, I'll get A. If I ask for the next Sj, I'll also get A. And then I'll get B out of that, and then I'll get C out of that. And what's going on with Si? Well, the last thing that it generated was A, so the next thing it should give me is B, and then C. And then once I hit D, that will be the last element, and I've reached stop iteration after that, and I'll get stop iteration forever after I've reached it once. So now we've created a letter iterator that lets us walk through element by element, and all letters is doing is giving us access to these different things so that if we want two different iterators over the same sequence, we can create those using the built-in special name iter, which is linked to this built-in function that just invokes the __iter method on its argument.